this, let us try to explore this concept here. Okay, see for example, a context-free grammar we are going to discuss now. Context-free grammar. Okay. Now, this is defined by what? This is defined by 4 tuple structure. First, what we need? A start symbol. Second, what we need? A terminals. Third, what we need? A non-terminal. And fourth, what we require? Production. Okay, so this is called as CFG. So these 4 terms we require, 4 tuples. Okay, these 4 tuples we require. Now, for example, just to understand this, for example, I have a language L which is based on a sigma here. Sigma is containing A. Okay, sigma is containing only one symbol A, and defined by regular expression as A star. Okay, then can we figure out? What is an equivalent CFG? Right? What is an equivalent CFG for us? Okay, so let us try to understand that here. If we look at A star, it means 0 or more occurrences of A, which means it contains epsilon, then it contains A raised to 1, A raised to 2, A raised to 3, A raised to 4, A raised to 5, so many, so forth, A raised to n, where n goes from 0 to infinity. Okay, so these are what? These are the production, these are the valid words, these are the valid words. Now, this regular expression can be easily transformed into equivalent grammatical representation. Okay, so what we have understood is that, okay, this particular symbol is going to be replaced as terminal symbol. This is a terminal symbol, and we understand terminal symbol as token, right? So we can write a context-free grammar here in this particular way, such that, say, in simple case, it contains a start symbol. So if I say A, capital A is implying okay, terminal symbol and non-terminal symbol. Capital A is, if it is, say, capital A is implying in a simple case, we'll say that capital A is implying rule says that alpha, A, or epsilon. Okay, capital A is implying alpha, A, or epsilon. If suppose I am writing this, so where is this question is it a CFG? Okay, so let us try to explore. So can we have a start symbol here? As per the definition, we know that start symbol is at the left side. Okay, this must contains non-terminal. So here this non-terminal is A. Okay, we know that the property of non-terminal is a non-terminal entity is represented in boldface letters, first letters, then they can be substituted. They can be substituted. Okay, means like you can question what is A? What is A? So A can be substituted as alpha A, or A can be substituted by epsilon. So this is by rule 1, this is by rule 2. Okay, so you can ask me like, okay, from where this rule 1 and rule 2 comes? Okay, so if I have a production, simply like A implies alpha A, that is form 1. So G with a production as this is 1, A implies alpha A, second A implies epsilon. So this is production 1, this is production 2. So this is rule 1, rule 1, rule 2. Okay, so I have got a start symbol. Start is A here. Okay, now let's figure out, do we have a terminal symbols here? Okay, terminal symbols. Okay, so we understand terminal symbols, specifically we call it as T. They are represented by what? Small face letters. They are represented as small face letters, and they cannot be, it cannot be extended, but can be substituted for non-terminal, but they can be substituted for non-terminal. In short, here, okay. So you can see like how these things are. Okay, so here we can see here as something terminal symbol. So for us, the terminal symbol for this would be alpha and epsilon. So simple case, alpha is alpha only, epsilon is epsilon only. So they cannot be replaced, right? Alpha is alpha only, epsilon is epsilon only. So they are small face letters. Okay. So you have got a start symbol, you have got a terminal symbol, you have got non-terminal symbols. Okay. And what are non-terminals here? Non-terminals, we have only one non-terminal, that is A. Okay, do we have productions? Yes, we have productions. So these are nothing but productions. So they are the productions. So I hope you have got it. So now, are they producing? So the question comes like, okay, we have validated, right? So here we have validated. Okay, so the regular expression is validated here. Okay, got it. So this regular expression is validated. Now we have to validate this. Okay, now as far as validation is concerned, so if my context-free grammar, if my context-free grammar which is supplied to me, CFG which is supplied to me is for a language L which is based on set of alphabet sigma containing A and defined by grammar with production as A implies A or epsilon. So this is the grammar A or epsilon. So here my start symbol is A, which is at the left side. Then terminals include A comma epsilon. Okay, non-terminal as A productions, since it has two parts, A or epsilon. So a grammar with production. So first is A implies A, second is A implies epsilon. Okay. So now let us try to validate whether it produces the same sort of word. Validation. Okay. So let us say that I want a first word as epsilon. So how it can be there? So how this word epsilon, that is null word, is being produced? So we have to start with, say, as I said, there are two approaches, right? Two approaches. What are they? Top down and second bottom up. So we have two approaches, top down and bottom up. So we will be exploring a top down approach. Means in case of top down approach, we need to start with what? Start with root to leaves. Okay, and from when it comes with bottom up, when we start with leaves to root. Okay, so it is likewise. So we have to start with root, and for us, the root must be a start symbol. Okay, here the root is start symbol. So means here we start producing this epsilon word from A. So like A. So question is like, okay, A, what is A, right? Can I substitute A? Yes, I can substitute A as epsilon. So the output is epsilon by rule of grammar production 2. Okay, so grammar production 2 means by using this rule, A can be substituted as epsilon. We can do this. Okay, can I have A? Right, so I can say what is A? A is AA. So this is by rule 1. Okay, by rule 1 means by using this rule. Okay, this is by using rule 1. Okay, then question is like, okay, what is, you still have a non-terminal here, A. So this non-terminal is to be, if it is being substituted by rule 2, so it means this is going to be A epsilon. So A is substituted by rule number 2 as an epsilon. So it is A epsilon. So A epsilon is A only. Okay, so you can produce A, you can produce epsilon. Now can I have two A's here? Okay, so can I have two A's? It is simple case. A is being substituted as AA. This A can be substituted as AA. From this, it is A here. This can be epsilon. So you can see that this is by rule 1. This is again by rule 1. This is again by rule 2. So it is here. If it is being substituted, this is going to become AAA epsilon. So AA epsilon is AA only. So can I have here, now can I have AAA? So A is being substituted as AA. This A is being substituted as AA. This A is substituted as AA. Now how many A's you have got here? 3 A's. Then this A is substituted as epsilon. So it is AAA epsilon. So the output is AAA. So which means that this particular representation, this particular grammar representation is an equivalent CFG for A star. Okay, it's an equivalent CFG for A star. Now we can think of like if you have a language L, which is defined by a set of symbol that is called sigma and being defined by A plus as a regular expression, then uh, what is equivalent context-free grammar for this? Right, A plus is the regular expression which we have. Okay, now I'm putting this question to you. You can unmute yourself and let me understand your answer. Yes, anybody?
सर इथे नल येणार नाही.
Null येणार नाही. So if it is not null, then what it is?
डायरेक्ट ए पासून स्टार्ट होईल सर. ए ए ए
Can you
ए ए ए.
can you no? Can you just tell me how it can be? You can tell me what is at the left hand side. Okay, just okay. I'm going to write now. Tell me, Pawan, what you wanted to say now here. Okay, as a solution, you said that this does not contains any epsilon, so this is epsilon free. Okay.
Yes sir.
Now, what should be the equivalent representation for this? So should I
Uh,
say A implies okay then
A,
okay A
small a, and
small a
capital A only.
capital A.
Capital A only.
Okay, fine. If it is this, let us try to understand. Like, okay, if it is in this case, what are the words that are generated by A plus? A plus words are A, 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 so many so forth, A raised to n, where n goes from n goes from 1 to infinity, right? So in this case, okay, so I want one A only now. Okay, I want one A. How you can generate for one? So you can start with this left symbol, right?
Sir, we can give or A in
Okay,
solution there.
so this can be A or A,
A.
right? Is it like this?
Yes sir.
Okay, so we have this form and this form. Okay, so can if like okay, so in this case, my productions will be G of P. This will be first A employing AA and second A implies A. Right. So if I want A only, then I have to write A is being substituted as A, and this is by which rule? Rule 2,
Rule
right?
2.
Yeah. If I want AA, then A is giving me AA. This A is giving me A, right? So it means here this is by rule 1. This substitution goes by rule 2. Right. Now, if I have if I want AAA to come here, so I need to substitute A as AA, this A as AA, and this A as A. So look at here. How many A's you have got? 3 A's. So this is by rule 1, this is by rule 1, this is by rule 2. I hope you got it right. If I have a grammar G which is defined by a set of productions as A employees A epsilon, and this is one grammar, then I can have G is giving me another representation as A or A. So this refers to A star, this refers to A plus. You've got it? So this is very simple. Okay. Now I'll just give you one more example to tell me what string can be generated. Okay. So means at the end of the day, from regular expression also you are generating string, from grammar also you are generating a string. Okay. So I am expecting answer from you. So let us try to have a simple grammar. You first tell me whether the grammar is context free grammar or not. Okay. So I'm just writing is this grammar is context free grammar. is this grammar is context free grammar. So if I say E implying E plus E or E minus E or in bracket E or E. Is this grammar is context free grammar? First answer, yes or no. Yes, what is your answer? Yes, what is your answer? Amani is saying yes. Is this grammar is context free grammar? The answer is the answer is yes. Okay, how? We have to see only four things. Start symbol is, do we have a start symbol? Do we have a terminal symbol? Do we have non-terminal? And do we have productions? Okay, so here how many productions are there in this case? See, E implies E plus E is one production. E implies E minus E is one production. E implies opening bracket E is one production. E implies A is one production. So this is going to be my rule 1, this is going to be my rule 2, this is going to be my rule 3, this is going to be my rule 4. Okay, non-terminals, how many non-terminals we have? We have only one non-terminal E. How many terminals we have? A. Okay, what is start symbol? Is E. Okay, so by this we can understand that this is what? This is context free grammar. Okay, now what is now question? This is what the question 1. Okay, now question 2 will be, what is a valid string generated from above grammar? What is the valid string generated from above grammar? Yes, tell me. So now you have got 4 rules here. Now, what are the valid strings that are generated by using this grammar? Can anybody tell me? Okay, hint. So I'm going to give you a hint here. So hint is, go for top down substitution. Okay, go for top down substitution. Then what can be the answer? Yes, you can unmute and you can tell me. Okay, do you think that this is going to be a little tough? Okay, let's see the solution now here. So you start by simple, by a leftmost symbol. You question E is being substituted by one of the alternative. If I say E is being substituted as A, so the valid string will be A, is first valid string. Okay, and this substitution is by using rule number 4. Okay, then second. Okay, if I say E is being substituted as E plus E. Okay, so the ultimate question is like, what is this E? E is being substituted by A plus E. Now this is being substituted by A. This is So you have got A plus E. So this is E is by E. That means what? Rule number one. Rule one. Okay, then E is being substituted by A. This is by rule number 4. Okay, then this is being substituted by this is by rule number 4. Okay, so then the next valid string will be this. Can I have A minus E? So it is E in bracket, E in bracket, E minus E. So this is by rule number 2. This E is A minus E. This E is A. So A minus A. So this E is gonna be this E is being substituted by okay rule number 4. So this is by rule number 4 actually. Rule number 4. So you have got this. Can I have say for example mm, fourth point, can I have A plus A minus A? Can I have this? Yes, I can have. E implies E plus E. This E is A plus E. This E is being substituted as E minus E. So we have got A, E plus E. Then this E is being substituted as A. So A plus A. Then this E can be substituted as E. Okay, so this is how I can go. Now, in more case, like can I have uh, can I have uh, can I have like in bracket A? Okay, so it is E in bracket E. This E is A. Okay, so this is by rule 3 and this is by rule 4. Okay, I hope you have got an idea like how the substitutions are being made, and this is really very interesting part. Okay, so what we have learned so far is what is the significance of this particular uh, phase, that is a syntax analysis phase. Then what exactly the context free grammar is. What exactly the context free grammar is. This is what we have learned so far.